Hello dear children, in a previous class of spectrum chapter, we discussed unit A. So let us recall the important points from that unit before going to discuss about the unit B children. So let us recall one important point children. What is color? Children, let us think here. What is a color children? So the light with a fixed wavelength is called color. Okay, fine. Then what is monochromatic light? Children, mono means what? Single. Chrome means what? Color. So monochromatic light, which means what children? The light with single wavelength or single frequency is called monochromatic light. Examples are what children? Orange color, red color, violet color, blue color. These all are the examples for what actually? Monochromatic light. Then what about polychromatic light children here? Poly means what? Many. Chrome means what? Color. The light which is consisting of more than one wavelength, more than one frequency is called as what children? Polychromatic light. So what is the best example for polychromatic light? White light. So white light is the best example for polychromatic light. In fact, white is not considered as a color. Scientifically I am telling you. Why? Because it is a combination of more than one color. Am I clear? Fine children. Now let us recall once again. What happens when monochromatic light is passed through a prism? Definitely there will be a deviation produced. So the deviation produced by the prism in the path of the incident ray only we can call it as a angle of deviation. So how to define the angle of deviation children? The angle through which incident ray gets deviated from its mean position, from its what we can say original path is called angle of deviation. So angle of deviation depends on mainly four factors. One is angle of incidence, wavelength or color of the light, and a refractive index of the prism and angle of the prism. Am I clear? Fine. Then what happens children when polychromatic light, that is white light, that is sunlight, is passed through a prism? Do you think that only deviation is produced? No. So here at a first refracting surface of the prism, what will happen? Light will get dispersed. So that phenomena only we can call it as a dispersion. That is what children here, when white light is passed through a prism, it gets splitted into its constituent colors. This phenomena of light is called actually dispersion. And these dispersed colors, these colors, when they obtained on a screen, only we can call it as a spectrum. Which means what? Spectrum is a result, dispersion is a cause. Then what is the main reason for dispersion children? Because different colors will travel with the different speeds in the prism. So that is the main reason for the dispersion. So here one important point, that is the examination point of view, we need to remember one important point. So prism has two refracting surfaces. The surface, the refracting surface on which sunlight is falling, there dispersion and as well as refraction takes place. Whereas at a second refracting surface from where they are coming out, there only what we can say refraction is possible. Okay children, so these are the very important point. So children, now we will be starting the unit B of this chapter, that is mainly about electromagnetic waves, that is electromagnetic spectrum. So before going to start this electromagnetic spectrum concept and a discussion, I would like to tell you one important thing. So important thing means don't expect that it might be related to the one scientific research or related to the physics. It is not that. So recently I have watched one movie that is called Karthikeya 2. Hey, I am not going to just share any story and all these things. It's not that. So in that one there is a conversation between Anupam Kher Sirji and Hero Nikhil actually. So I am not going to tell all those dialogues and everything. So in the dialogue I will try to tell in my own words whatever I liked actually. So in that the dialogue, so it is like this. If you are not able to see something, if you are not able to see something, it doesn't mean that it is not existing. Children, I repeat once again. If you are not seeing something, which means that that something is not existing. Am I clear? Which means what? If you are not seeing means we may not have proper technique to see it. So don't conclude that it is not existing actually. So then why I am sharing this dialogue means this dialogue exactly suits to our discussion, today's discussion especially. So let me tell you how it is. Children, we know that when a sunlight is passed through a prism, we know that we will obtain VIBGYOR, that is we will obtain the spectrum. It's very clear. But the question is that beyond means here violet and red color, these are the extreme color of the spectrum. And these region of the light, can excite our retina so that we are able to see. That's what this is also called as visible spectrum. Now the question is that beyond red color, beyond violet color, we can't see anything actually. Which means what actually, if you are not seeing means, can we say that nothing is existing there? No, it is not that. If you are not seeing means, you cannot say that nothing is existing. You are beyond violet color, beyond red color. Am I clear? Yes. So after what we can say discussion of this visible spectrum and everything, after so many experiments, they have so many experiments proved that so beyond this red color and before this violet color also some other radiations are existing. But you may get one question here. Sir, if they are existing means why are we not able to see? Yes. So beyond violet color, beyond red color, what are the radiations are there? They do not excite our retina actually. So due to which only what will happen? We cannot feel those radiations. Am I clear? So the radiations which are existing beyond red color and violet color are together called invisible spectrum. Okay na? So beyond this red color, what will be there here? Infrared radiations are there. Infrared radiations are there. Next of infrared radiations, microwaves are there. Microwaves, and beyond microwaves we have radio waves. We have radio waves. Fine. Till date I am talking here. Now here means before this violet color we have UV rays. Then here we have X-rays. And here we have gamma rays. We have gamma rays. So children, try to understand. Here to here it is invisible. It is invisible spectrum. Let us say it is a invisible spectrum. It is, and whereas here also it is what actually invisible spectrum only. Invisible spectrum. So children, this visible spectrum and invisible spectrum together only we can call it as a electromagnetic wave, electromagnetic spectrum actually, electromagnetic spectrum. Children, this is till date only. Who knows? In the future, you may become a scientist, you may discover some other radiation which are existing beyond radio waves and here beyond gamma rays also. Children, till date only it is applicable. Again I am telling you, who knows? You may become a scientist, you may discover some other radiations. Again I am telling you, let us recall that movie dialogue. If something is, we are not seeing something, it doesn't mean that it is not existing. So now beyond radio waves, beyond gamma rays actually, now let us say that now nothing is found due to some scientific techniques also. It doesn't mean that that is not existing. So in the future new techniques might come, new discoveries might come. They may prove that yes, beyond gamma rays, beyond radio waves, yes, it might exist, some other radiations also might exist. But examination point of view, we should not at all these things. In the future it might exist, we discover, that is the future. So till date here gamma rays, X-rays, UV, VIBGYOR or infrared, let us write infrared, okay, infrared, microwaves, radio waves. This is entire thing only we can call it as a electromagnetic spectrum. Children, here if you can see this in this electromagnetic spectrum here, so radio waves have high wavelength, whereas gamma rays have low wavelength. So high wavelength, or you also can call it as a low frequency, and here you can call it, even it is also we can say it's a high frequency. So children, in examination point of view, yes, this is a very important. How the questions can be asked. Now if you can see here, gamma rays are the lowest wavelength, radio waves are highest wavelength, which means what here, gamma to radio here wavelength is increasing. So in exam, if they will ask you a question like this, write the names of the electromagnetic spectrum in ascending order of wavelength. Ascending means what? Low to high. So you have to start with the gamma, then you have to end with the radio waves. Or the question might be asked like this also, write the names of the electromagnetic what we can say spectrum, like a radiation's names in a descending order of the wavelength. Descending means what actually? Highest wavelength to least wavelength. So you should start from radio. So you should start radio, micro, infrared, visible, UV, X-rays, and you should end with the gamma rays. So this is very important. So when they will ask you in exam, so you should be very careful. Are they asking ascending order of wavelengths or descending order of the wavelengths? Is that clear? Fine. Now children, so here one important thing is that these radiations might have, these radiations will have different wavelengths. Though they have different wavelengths, children, they have a common properties. So examination point of view, the common properties of electromagnetic waves are very important. So what is that common property, children? So here first property, the common property, first property, the thing is that, so these waves, these radiations do not require any medium. That is the reason why we are getting from the sun, because in between vacuum is there, so nothing is there. Am I clear? So these electromagnetic waves, electromagnetic radiations do not require medium. Fine. Okay. And the second, so do not require medium. Do not require medium. So the second point is that, children, they can travel through air or vacuum with a speed of 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. The third important point is that, children, if these electromagnetic radiations are passed through electric and magnetic fields, what happens? They do not deflect. Why? Because they are not charged one. Am I clear? Fine. So these radiations do not deflect in what we can say electric or even magnetic fields. In exam they may ask you a question, why? Because they do not possess any charge. And the fourth one is the, children, so these electromagnetic waves or radiation, they will travel from one medium to another medium. Children, as long as they will travel in air or vacuum, they will travel at the same speed. But the moment they will enter into the different, means in a different mediums, they will travel at different speeds. And one more thing is that, so whenever these electromagnetic radiations are traveling from one medium to another medium, what will happen here? So refraction takes place. I mean what here? They will bend. Even they also will show a normal, like like a normal, they also will show the reflection also. Okay, fine. And yet what is the nature of the electromagnetic radiation? The nature of the electromagnetic, so they are transverse. In nature. So which means what, children, here? So why they are in transverse in nature? Because electromagnetic radiations are consisting of oscillating electric and magnetic fields. So children, these are the properties of electromagnetic radiations or electromagnetic waves. So let us recall once again. They do not require medium. They can travel through air or vacuum with the same speed. But the moment when they will enter into any other medium, they may travel with the different speeds. And they do not deflect in electric and magnetic fields because they do not possess any charge. And they will show normal light, the reflection, refraction, all these phenomena they also will show. And when they will travel from one medium to another medium, they will bend from their what we can say original path. And they are in transverse in nature. Why they are in transverse in nature? Because they are consisting of oscillating electric and magnetic fields. Okay, children, fine. Now, fine, children. Here, one important point we need to discuss. What is that here? Children, what is the wavelength range of VIBGR? It is 4000 angstroms to 8000 angstrom. That is fine. What about infrared? Infrared is 8000 angstroms to 10 power 7 angstrom. What about microwave? Microwave is 10 power 7 to 10 power 10 angstrom. What about radio waves? The wavelength of the radio waves is greater than the 10 power 10 angstroms. Now come to the UV rays here. So the wavelength range of the UV rays is what we can say, this is 4000, right? So it is 100 to 4000 angstroms. 100 to 4000 angstrom. Whereas X-rays, if you can see, this is 0.1 angstrom to 100 angstrom. Whereas for gamma, it is the less than 0.1 angstrom. Children, in examination point of view, sometimes they may ask in a nanometer also. Don't get confused. Children, here 1 nanometer is equal to 10 angstroms. 1 nanometer is equal to 10 angstrom, which means what? Just you divide all these things with a 10, then you will get a particular wavelength in a nanometer. So just let me tell you example. So this is, for example, 4000 angstrom to 8000. So divide with the 10, this will be 400 nanometer to 800 nanometer. That's it. If you want this one example, this is 10 to 400 nanometer. So it is not a big task. So no need to buy hat again. So once you know the wavelength range in angstrom, it's very easy to express even in nanometers also. Children, here one important point we can notice. For suppose I'll ask you a question now. Name the electromagnetic radiations with the wavelength 4000 angstrom. Then children, here you may get a one doubt. Sir, 4000 angstrom means here violet color. I think visible spectrum is static. Whereas 4000 angstrom means what? UV rays also ending. Then what should we write? Is it UV or visible spectrum answer? Of course, children, don't get confused. This kind of questions won't be asked. So actually what is my intention is that I want to tell you that, children, here there is no sharp boundary between electromagnetic radiations. Means you cannot say that from 1 to 2 is X or 3 to Y. So there won't be like that. Here means what? The wavelengths of the boundaries of the wavelength, they got merged. The wavelengths, again telling you, the boundaries of the wavelengths of the radiations got merged. So there is no specific boundary. There is no specific boundary. So that's what Wantely ask you a question. So don't get tense. Those kind of questions won't be asked. So these then how the questions can be asked? They will ask question like this actually. So why I am telling is some students they may ask me doubt actually. Sir, should we remember all these things, wavelengths? So now just let me ask a question, then you only will understand. Should we remember or not? Name the electromagnetic radiations with a wavelength 10 angstroms. Then 10 angstrom means we need to check 10 angstrom, 10 angstrom, 10 angstrom. Yes, X-rays here, it is falling here. So if you don't have an idea about the wavelength range, then how can you answer to these kind of questions? So just idea, just having idea from where to where actually. Okay, children, fine. So this is about electromagnetic spectrum and their what we can say their wavelength range, and we also studied the common properties. Now children, so we will try to study the what we can say about electromagnetic radiations individually. I mean examination point of view, whatever is important, that much only we will learn. Okay children, fine. So let me erase this. Hope you have copied this. Can I erase? Yes. So the first one is gamma rays. So children, the first point. So here who discovered this gamma rays, children? So gamma rays are discovered by, we can say that's Henry Becquerel and even Madame Curie also. Okay. So but examination part of it, they don't ask you the scientist name actually. So children, the wavelength range of the gamma rays is, less than 0.1 angstrom or 0.01 nanometer. Is it clear? Fine children. Then what are the sources, children, here? So radioactive emission. So we have a special chapter, of course, we need to discuss that. Still we have not discussed, that is radioactivity. The radioactivity we will be discussing about the radioactive emission. So radioactive emission is consisting of gamma rays. So here what are the sources? So in exam they may ask you about the sources. That's very, very clear. So here, so radioactive emissions, radioactive emission, and even these are present even in cosmic rays also, children. Even they are present in cosmic rays also. And here the thing is that then what is one of the important property examination point of view? What is that here? These gamma rays have high penetrating power. These gamma rays have high penetrating power, which means what? They can penetrate very, very, very easily. Means they can penetrate through a human flesh is very easily. That's what these gamma rays will do more biological damage. It's too dangerous also. Okay, fine. Then what is the use, children? So the main use of these gamma rays is that these are used in radiotherapy. This is very, very important. Radiotherapy. So because of their high penetrating power, high penetrating energy levels only, these are used in radiotherapy. Children, Therapy means what? The disease means the process of curing the disease actually. So mainly gamma rays are used to kill the cancer cells, to kill the here cancer cells in our body. That what in the patient body. Okay. So examination point of view, the wavelength and the source and the application part is very important. Is it clear? Fine. Now second one. Fine. So the second one we will be studying about the X-rays. So we will be studying about the X-rays. So children, here it is discovered by Rontgen. So children, this is a very important. So here there is a one specialty is there for this scientist actually, Rontgen. So this question is very important even for a GK point of view also, because Rontgen was a scientist who got first Nobel Prize in the physics field actually for the discovery of X-rays. This is very important. Okay, children, fine. Now what is the wavelength range? So the wavelength 0.1 angstroms to 100 angstroms, or you can say in a nanometer if you want to express, it will be 0.01 to 10 nanometers. 10 nanometer. Is it clear? That's fine. And how they are obtained, children? So here if you can see, this is let us say one target which is made up of with a molybdenum, which means what? The material with a high melting point. When cathode rays are stopped, let us say when cathode rays are stopped by the material like a molybdenum with a high melting point, what happens? Here we can get a X-rays. This is how actually they happen. In shortcut I am telling you, I am not going to explain in detail. Is it clear? Fine. Now here properties means like gamma rays, they also can show the fluorescence property. When they can hit the fluorescent material like a zinc sulfide, they may cause fluorescence. Even these X-rays like gamma rays also can affect the photographic plates. Okay, fine. And come to the application, children. So the very important thing is that they are used in radiography. They are used in radiography. Children, many students they have a confusion. They'll get confused between radiography and radiotherapy. Radiotherapy is a method of curing the disease. Radiography, taking a photograph of our skeleton. I mean, taking a photograph of skeleton. Children, so if anyone has this feel that I'm a beautiful, I'm a handsome, I looks very smart and all these things, just once you can notice your X-ray, then you don't have all these things feeling. They will go out of your mind. Am I clear? So once you can see your skeleton, that is X-ray of our body, you don't have feel of beauty and handsome, smart and all these things. Okay, fine. So here radiography. What is the radiography, children? Means the method of detecting the actual fractures in a bone. That is to detect fractures in bone. So not only that, children, even to study the crystal structure, also these X-rays are used. Okay, children, just to copy this. Next we discuss about the UV rays. So now we see the ultraviolet rays. So the third one is what actually we are going to see about the UV rays or ultraviolet rays. Children, it is detected by a scientist named Ritter. So Ritter. Children, I am just sharing the information regarding the scientists and their discovery, but in examination point of view it won't be asked. And children, examination point of view, UV rays and infrared radiations are very important. Is it clear? Fine. Now first let us see what are the sources. So for the sources, so what we can say, mercury vapor lamp, even sunlight. Children, of course sunlight may consist of much portion of the UV rays, but ozone layer is protecting us from a UV rays. Is it clear? Fine. So here is Ritter, just what we can say, he discovered a UV rays, and the main source is mercury vapor lamp, even arc lamp also, and even sunlight also. And children, very important, the detection is very important. detection, children. How these are detected, children? These are detected by their chemical actions on dyes. And here one means especially if you can see, children, for suppose let me take here some solution. So what is this name of solution, children? It is the solution of silver chloride. Solution of silver chloride. Children, when this solution of silver chloride is exposed to UV rays, then what happens? What happens, children? This silver chloride, first it will turn into violet color. First it will turn into violet color. If it is exposed much, if it is exposed for a long time, then it will turn into dark brown color. Dark brown or black. Dark brown or black actually. Okay, children. So again I'm telling you, so they are detected by their action on dyes. When the cloths are they are placed outside for sunlight, what happens? Sometimes they get faded up, the color will go off. Why? Because this UV rays has ability to break the bonds of the colors actually. Am I clear? So that the color will be changed. Am I clear? Just you can notice whenever your shirts or any pants they are placed for a sunlight to make them dry. So definitely there will be change in the color. For that, the main reason is what actually is the UV rays. Okay, fine. And children, examination point of view, very important. How can you obtain the UV spectrum? How can you obtain the UV spectrum? UV spectrum. Are you able to see this? Whatever I am writing about, let me check. UV spectrum. Yes, exactly. I think UV rays are not visible. Okay. I think it is UV rays. So next I'll try to write a little bit less height. Okay, fine. UV spectrum. Children, just let me give you one simple clarity. Let us say one prism. For suppose here all electromagnetic radiations, they are allowed to pass through this prism, and here surprisingly here we get here UV what we can say rays, UV spectrum. Let us say we get here UV spectrum only. UV spectrum. Children, it is possible only when this particular prism, only this special prism can absorb all radiations except what? UV radiations. Then what is the name of that? Examination part is very important. So how can we obtain the UV spectrum, children? So for that we use quartz. Quartz prism. Children, it's very important. So quartz prism is used to obtain UV spectrum. In exam they may ask a question, why can't we use a glass prism? Because glass prism even it can absorb even UV rays also. As it is absorbing UV rays, we won't get UV rays only. Then how can you obtain the spectrum? Is it clear? So here quartz prism is used to obtain the UV spectrum. Clear, children? Fine. Now come to the what are the place points. Let us see. What are the place points, children? So these are used to detect the to check the purity of the eggs, purity of the gems, and even, children, recently during the corona sterilization, during the corona, what happened? I don't know whether you noticed or not. So we had a kind of machine, where actually UV rays are produced. The objects they are used to place in that, so that what will happen? What we can say, if any virus is there, it is a kill actually. They are killed actually. Even I have noticed, many education institutions after conducting exam, they used to place that exam papers bundles in a UV boxes actually. Is it clear? That is fine. And even, children, they are also used to what we can say for the to check the adulteration of the ghee. And one more very important point, it is directly related to our body. What is that here? When our body is exposed to the what we can say this UV rays, not with a much intensity, with a very light intensity, D vitamin is produced. It's a very important to store the what we can say calcium in our body, so that what will happen? Our body will become very strong. So these are the positive sides. Then what are the negative sides, children? Yes, when this you can see the UV rays directly, when your eyes gets exposed to UV light, what will happen? Our retina may get damaged, and even our skin is exposed to a much time for a UV rays. What happens? Skin burning. It may cause us to skin cancer also. Okay, children. So these are the very important points regarding the UV rays. So after this, what we have? We have a visible spectrum. Children here, now hope it is copied. Fine. So visible spectrum, children, examination point of view, the wavelength is very important. Wavelength. So look at here. So now the fourth one, which we'll be discussing about a visible spectrum. Visible spectrum. That is what actually is a WIBGR. So this is by actually Sir Isaac Newton. He discovered this one, the this visible spectrum. So which is a part of a sunlight is discovered by actually Newton. When sunlight is passed through a prism, what happened? So we discussed that. So due to the dispersion phenomena, so these 7 colors are obtained actually. Then what is the wavelength range, children? Here the wavelength range is 4000 angstrom to 8000 angstrom. So if you want in nanometers, just divide with the 10, you will get, that is 400 nanometers to it is 800 nanometer. Is it clear? Fine, children. The main source, yes, sunlight only. Sunlight is the main source. Okay. So what is the main purpose actually, children? So here uses, let us see here. So visible spectrum, especially this visible light is used in a photography, right? So because if this light is not there, are we able to do the photography? No. Still now also I am able to record my video, which means what? Here you are able to see my video, which means what? That light is falling, visible light is falling on my body, and which is getting reflected and which is recorded by my camera. Of course, it's my mobile, it's not camera, it's a small mobile we am recording. So I'm not using any, what we can say, big cameras, but just my pocket, whatever the mobile which I use, with that one I'm recording. So it is possible only with a visible light. And even children, so we are living because we are eating a food. From where we are getting mainly? Yes, trees. So how they are preparing the food? Photosynthesis. So this visible light also, it's a very useful in a photosynthesis process. Okay, so this much is enough for a examination point of view. Now children, here we discuss about the infrared radiation. Children, examination point of view, UV rays and infrared radiations are very important. Okay, fine. Now, so I think it is the fifth one, infrared radiation. So these are discovered by Herschel, children. These are discovered by Herschel. Fine. And what is the wavelength range, children? The wavelength range is, it is beyond radical light. It is a 8000 angstroms to 10 power 7 angstrom, or it is 800 to 10 power 6 nanometers. Children, here what are the sources here? What are the sources? So here children, here very, what we can say, all red hot bodies, very important. So here all type of red hot bodies they will emit. Of course, even sunlight also. Children, even when you are taking iron, the iron box, when it gets heated, yes, it can emit. Even water heater, when it gets heated too much, when it will become a red color, yes, it also behaves like a source of course it emits the infrared radiations. Of course it emits actually. And children, here the important thing is that these IR radiations are also called as heat radiations. Children, it's very important. Heat radiations, that's what these are detected by blackened thermometer. Blackened thermometer means, in a if you wanna test, if you wanna detect, for example, let us say it's a visible spectrum, let us say what we can say, VIBGYOR. Let's say black and it's like a black end is there. So let us say it's a black end bulb thermometer. So when it is like moved from violet to red color, so slowly you can feel that you can notice the raise in what we can say a mercury level. But the moment when it's taken beyond red color, so surprisingly you can see that the level of the mercury will rise like anything. Which means what here? Yes, beyond the red color you may not see the radiations present. But when this blackened, what we get, the thermometer is moved beyond red color, it is showing much reading. Which means what here? Some radiations which are existing, which are not visible, but which may causes heating effects like anything. That's what the radiation which are existing beyond red color are also called heat radiations. Then how can we detect, children? How can we detect this? So for this we use black end thermometer. Black and thermometer, and even we also can use thermopile. Children, we also can use thermopile. That is fine. And here, how can we obtain infrared radiation spectrum, IR spectrum? Children, for suppose here, let us take here is, yes, look at it. For suppose, look at here, I need a space here. So let us say here is all electromagnetic radiations, they are passed through this special prism. Then here only we got IR spectrum. Is it clear? Fine. But examination point of this name is very important. So what is that prism? So how can we obtain the infrared radiations or IR spectrum actually? Children, this is rock salt. It is rock salt. We know rock star. Okay, fine. So it's a rock salt. Children, it's an examination but very, very important here. So rock salt prism is obtained to get the what is used to obtain a infrared spectrum actually. So why not a glass? Again, glass prism can obtain all radiations including infrared spectrum. Is it clear? Fine. And children, come to the application part. So before that, before going to discuss the application part, we need to understand one important point. These infrared radiations have highest wavelength. You may get one doubt actually. Okay, sir, if they have highest wavelength, what is the point here we need to learn here? Means, let me tell you children here. So intensity of scattered light is inversely proportional to the fourth power of the wavelength. Of course. So this is a very important point to understand the next unit actually. Next unit completely we will be discussing about this point and its applications. Just for today, just try to understand what does it mean. So intensity of scattered light is inversely proportional to the fourth power of the wavelength. Okay, fourth power or third power or second power, that you leave it. Inversely proportional, which means what? More the wavelength, less the scattering. Less the wavelength, more the scattering. Okay, na? So as infrared radiations are having highest wavelength, high wavelength, so they'll get less scattered, they'll get less deviated. So this property, because of this property, we will find many applications. Am I clear? Fine. So here, first important one actually. So because they will get less scattered, so they are used photography, means during a night photography here. They are used in a photography. During night, because it will give that visibility. Okay, night, and even they can penetrate through mist, and they can penetrate easily through mist and fog without getting scattered. Okay, now fine. And even here, photography means children. Let me try to tell you example. I don't know if you have seen some movies where completely based on the investigation movies. There one dark room will be there. Police or the great police people. They'll try to develop some film. Photographic film actually. If you can see that room, it is almost like a reddish color. Red color it is. Here, it is nothing but what light actually? Infrared light only it is. Infrared radiation means. Then you may get one doubt, sir, why they are using infrared radiations? Two reasons. One is infrared IR radiations. They will provide this vision effect so that they can able to see. And second thing is that IR radiation, they do not show the impact on photographic film. Am I clear? So because of this reason, I don't know when you can come across with any investigation movies. There you can see that particular dark room. Dark also, that room only, but it's a reddish color it will be there. That is the infrared radiations only. So they will provide the vision, and they do not show the impact on photographic film. That is the reason why they are using photography. Is it clear? Fine. And these are also used, as a, they are used in a war as a signals. Why? What is the reason? Because they are not visible and they are not absorbed much by the what children, even atmosphere also. So that is the reason why even they are used in a war as a signals. Okay, fine. So what is the negative impact? Yes, when these radiations are exposed to much, what will happen? It causes skin burnings and many other factors also. Okay, na? So examination point of view, examination point of children. So how can you detect and which prism do we use to obtain IR spectrum, and the applications are very, very important. Okay, just copy it. Fine. So now the sixth one is microwaves. Sixth one is the microwaves. So just the discovery for who is the reason? Yes, for this discovered by Hertz. Children, we can use now the units of frequency Hertz. Okay, na? So he is that the scientist only. He is a Hertz only. So what is a wavelength range, children? Here the wavelength range is 10 power 7 to 10 power 10 angstroms, or it is 10 power 6 to 10 power 9. It is nanometers. Nanometers. So here, what is the source, children? Here, crystal oscillators. Crystal oscillators. Children, regarding this crystal oscillators, you learn in a higher studies, not required here. Crystal oscillators will produce these what we can say microwaves. So examination point of view, applications are very, very important. So what are the applications or what are the uses, children? So mainly these microwaves are used in a satellite communication. Mainly satellite communication, satellite communications, and even microwave use, and even they are also used in radar communication also. Okay, na? Fine. Now come to the the last one, children, that is what actually radio waves. That is radio waves. Fine, children. So it's a discovered by here Marconi. Discovered by Marconi, and the wavelength range is greater than 10 power 10 angstrom or greater than 10 power 9 nanometer. So here these are used much in radar communication. Radar communication, and even they are also used TV, radio communication, children. And the very, very important thing is till date these radio waves are the electromagnetic radiations with a high wavelength. They can travel for a long distances by carrying the messages. That's what they are used in TV and radio communication. Okay, children. So these are the important points regarding what actually electromagnetic spectrum. Children, once again let us recall the Karthikeya to the dialogue. What is that? If we are not seeing something, it doesn't mean that something is not existing. Okay, children. So that is the main point actually behind all these things. So other than this VIBGR, we cannot see. So the spectrum which is not visible is called actually invisible spectrum. So visible spectrum plus invisible spectrum together we can call it as a it's a electromagnetic waves, electromagnetic radiations. Children, again I am telling you what you have to do it. First, read the textbook. This is very, very important. So textbook is the ultimate source. First point. Second point, while reading the textbook, try to have your one notes with you so that you can note down the important points such that you can make your own material. So after that, just try to go through the example questions discussed, example numericals discussed in the particular chapter. And after that, go through the exercise questions. So this is what actually you have to follow to get a command on particular topic. Okay, children. Thank you so much. All the very best.